Hi girls, and welcome to another exciting video about redox chemistry. Today's one we're going to look at balancing redox equations in basic conditions. Now this is very much an extra for experts kind of topic, so if you find that you're struggling with redox chemistry, I would highly recommend right now that you actually turn off this video and either go back and have another look at the first balancing equations video, or you move forward and look at the next one. However, if you are wanting to challenge yourself or you're thinking about doing scholarship chemistry, then this video might be useful for you. So what we're looking at here is balancing reactions in basic conditions. We've done a lot in acidic conditions, but this is the first one we've done in basic conditions. So the general rules are that you balance it exactly the way you would in acidic conditions. But once you've got the reaction balanced and finalized, then you add OH minus ions to both sides of the equation, which cancel out any H plus and leave some OH minus behind. This first example I've got happens in basic conditions, but in fact the OH minus ions don't feature in the overall equation. When you break it down and you take your first step and you are turning your ammonia into hydrazine, then you've got two H pluses and two electrons which you have to add into the reaction. Same deal when you do your chloride to chloride. Again, you've got two H plus and two electrons on the opposite side. So when you balance the equation overall, they all cancel out. That's not unusual, and it does make life a little easier sometimes. However, the next example I've got is a little more complicated. So in this case, we have bromide, there's a little minus beside the bromine there, and permanganate making bromate and manganese dioxide. Sorry, that should be a plus manganese dioxide, not an arrow to manganese dioxide. Okay, so we can break that into two half equations. First we have bromide turning into bromate. Then, to balance that equation, we've got one bromine on each side, that's all fine and dandy. We have three oxygens on the right-hand side in the bromate, so we need to add three waters to the left. That gives us then six hydrogens, so we add six H plus to the right-hand side, and then six electrons to balance it all out. Permanganate can actually turn into a variety of different things, including manganese dioxide. In the past, we've always done the ones where permanganate turns into the Mn2 plus ion, and that's what happens in acidic conditions. But in neutral and basic conditions, we do get different products. So here's one of the options, manganese dioxide. When we balance this, we've got one manganese on either side, that's great. We have four oxygens on the left, two oxygens on the right, so we need to start off by adding some water. I'm going to add two waters to the right, which is going to balance out our oxygens. That's then going to give us four hydrogens, so we need four H plus on the left and three electrons. Now, of course, you'll notice that the first half equation, bromide to bromate, releases six electrons, while permanganate to manganese dioxide gains three electrons. So we need to multiply that equation by 2 so that our electrons become equal. Okay, so we have now two balanced half equations with equal numbers of electrons. We can then combine that to make an overall balanced equation, and we can simplify that by cancelling out the excess waters and H pluses. There's our nice final equation. Now, if this was in acidic conditions, then that would be a lovely balanced equation. Unfortunately, because this reaction happens in basic conditions, there is no H plus ions around, not excess anyway, to react. So to finalize this equation and actually have it balanced in basic conditions, what we need to do first and foremost, we've got two H pluses on the left-hand side of the equation. So we're going to add two OH minuses to both sides of the equation. This is a bit like maths. You can do anything you like to an equation as long as you do the same thing to both sides. So here we go, two OH minuses to either side of the equation. Now on the left-hand side, if we've got two OH minus and two H plus, they are going to react together to form two waters. Those two waters will then cancel out the one water, or one of the waters on the right-hand side of the equation, so we can simplify that equation down to give us a final overall equation. And what you'll see with that is that that is totally balanced and it is in basic conditions. So let's just check to make sure it is balanced. So we have 1 bromine on the left-hand side and 1 bromine on the right-hand side. 2 manganese on the left, 2 manganese on the right. We have 1 oxygen on the left from water and 8 from the permanganate. So that's 9 oxygen on the left altogether. We have 3 oxygen on the right in the bromate, 4 in the manganese dioxides, and 2 in the hydroxides. That gives us a total of 9 on the right as well. Hydrogens, we've got 2 on the left and 2 on the right, so that's all good. And we have 3 minuses, 1 from the bromide and 2 from the permanganates on the left, and 3 minuses on the right, 1 from the bromate and 2 from the hydroxides. So all the atoms are balanced, all the charges are balanced. That is a balanced redox reaction in basic conditions. That's the general process that you use, and I hope you found that useful. Thanks very much, guys. Catch you next time.